Hello, this is exercise 12F. We're looking today at trying to find areas between two curves. So it could be quite nice ones where you get a straight line and a curve, and it could be quite complicated ones where you've got to do quite a bit of work above and below the axes, for instance, as well. So when we're doing these, I suppose there's two approaches. On the one hand, you could find the area of the top curve. And in this example here, that would be giving me all of this area here, so the area underneath this curve. And then I might then, for instance, find the area underneath the bottom curve. And if I subtract one away from the other, presumably it'll give me this blue bit. And that's what this is meant to be saying. This is the top curve minus the bottom curve. And I could integrate the top curve, integrate the bottom curve, take one away from the other, and I'm sorted. Now, the alternative is to do the subtraction before you integrate, and it definitely has an advantage of only requiring one integration. And if I write it like this, perhaps you can see it more clearly. It's the f of x minus the g of x. Now, you've got these modulus signs, which basically try to ignore the fact that some bits are underneath or above the axis, and it basically carries it out in a really nice, easy way. So we're going to try and do that in this section of work. So this example says find the area between the two curves, the exact area required by the enclosed by the curve. Now, I suppose the first thing we need to know is what's it look like. So type it into your calculator and see if you get the same as me. This is what I get. So but definitely do type it in. So that's what I get when I've typed in, obviously, the x squared curve and a straight line. And I want the area in between. Now, straight away, what it implies is there's 2 points here that I need to know where they are. And I'm not 100% sure. This looks like I'm not even sure. They look like 1,8, but not definite. And this, I've really no idea what that is. So I need to find them out. And the way you do it is you solve the simultaneous equation. So you go x squared minus 6x plus 13, and you set that equal to half x plus 15 over 2. Move the half x over, I get x squared minus 13 over 2x, 6.5 if you like. Now that's plus 7.5, move that over, it becomes a minus, so is that minus 11 over 2, that's 26, yes, that works. I don't like that at all. So I'm going to write 2x squared minus 13x plus 11 equals 0. Now I chuck that into my calculator. I could have done it in the step before, admittedly, but that's the equation I've come up with. So clear this menu A, and it's a polynomial of degree 2. So we've got 2x squared, I've got negative 13, and I've got 11. And probably best to show this. There might be marks available for doing this. So I get x is 11 over 2. Is that point there? Yeah, it probably is. And my second one I'm hoping is 1. Yeah. So I've got two solutions. X equals that and x equals that. So if I want this area, I basically now do the integral of the top curve minus the bottom curve dx. That's what I'm going to do, particularly as it's all above the line. And it's in between 1 and 11 over 2, because they're the numbers I just found. Now, what is the top curve? The top curve is actually the straight line. In between this area, the top curve is definitely a straight line. So I'm going to write half x plus 15 over 2 minus, what was this? It was x squared minus 6x plus 13 dx. Now, I'll tidy that up a bit. It's the integral from 1 to 11 over 2. Now, it's a minus x squared. I've got half x minus that 6x. And what you'll find is you'll actually get these things over here all repeating themselves, possibly the other way around. So this is going to be plus 13 over 2x. It always amazes me when you do that. It gives us the same answer. Minus 11 over 2 if you do it, dx. So let's integrate it. So minus x squared goes minus x cubed over 3 plus, now it's going to be x squared, so it's going to become plus 13 over 4 x squared minus 11 over 2x. And that's between 1 and 11 over 2. So obviously what I now need to do, I need to substitute 11 over 2 into this, substitute 1 into it, take them away. Now I'll be honest, I did this earlier. So when I typed in 11 over 2, you'll need to check it. I got 605, not very nice, but that's over 48. And then when I put the 1 in, I got 31 over 12. So I took one away from the other, and I got 243 over 16. But you'll need to check my maths. Chuck those into your calculator and see if you get the same answer. I think that's the right answer. Yes, it is. So that's the first example. Here's a second example. And again, it's find the exact area enclosed by these two curves. First job, what the hell do they look like? That's what they look like. This is the curve here, is y equals e to the x minus 3. And this one, by definition, is y equals 5 minus 7 e to the minus x. And you can see they definitely seem to cross at two nice places. But you've got to prove it, I suppose, potentially in the exam. So we'll do it here. To find where they cross, you set them equal to each other. And it's not very nice, actually, but it becomes a disguised quadratic if you think about it. That move everything over there, plus 7e to the minus x minus 8. And to make this into a disguised quadratic, times everything by e to the x. That's what we did in year 12, I think. E to the 2x plus, well, that becomes plus 7, so I'm going to write that there. And minus 8 e to the x. So this is can be simplified. Now you could do it. I reckon it's e to the x minus 7, e to the x minus 1. You could do it on your calculator if you want, and you end up saying e to the x equals 7 and e to the x equals 1. Therefore, x equals the log of 7 and x equals the log of 1. Now, the log of 1 is 0. So that one was right. Actually, this is not what the number I thought it was. I thought it was going to be equal to, say, 1 or something, but it turns out to be log 7. Now, what is log 7 equal to? Do it on a calculator. Log 7 equals 1.94. Alright, so it does seem as if it doesn't quite. Lost my pen. There's my pen. Not quite there. It's obviously 2, 4 going up like that. Anyway, that's my numbers. So to find this area in between, I'm looking for this area here. I integrate between 0 and log 7. I do top curve minus bottom curve. What's the top curve? It's that one. So it's 5 minus 7 e to the minus x minus the e to the x minus 3 dx. And that is equal to the integral from 0 to log 7. Now 5 minus a minus 3 is 8. And I think when you do this you get 8. I'm going to write minus 7e to the minus x minus e to the x dx. Just check that. Integrate, I get 8x. I get plus 7e to the minus x minus e to the x between 0 and log 7. Put those in, I get 8 log 7 plus 7e to the minus log 7 minus e to the log of 7. And if I put 0 in, I get 0 plus 7 minus 1. So this is 8 log 7. This actually, this becomes e to the minus log 7 becomes a 7th. So it's 7 times a 7th, which is 1. And this is minus 7. Minus, what's this? This is 7 minus 1 is 6, minus 6 more. So that's 1 minus 7, that's minus, I get 8 log 7 minus 12. What is it, minus 12? Yeah, good. It actually was the answer as well. Always helpful. Third example, x squared minus 3x over 1 curved line is 2x. So, same again. Draw it on your calculator. You probably get a good idea where they are, but just use a bit of algebra to see exactly where they cross. Set them equal to each other. x squared minus 5x equals 0, x minus 5, and therefore x equals 0 or x equals 5. And that probably looks fine to me, yeah. So if I find this area, it's the integral from 0 to 5 of top curve. What's the top curve? Well, this is my top curve actually. It's 2x. And this is my other curve, my bottom curve. So I'm going to do the 2x minus the x squared minus 3x dx. And if I do that, I get 2x minus minus, I get 5x. I get minus x squared dx, again between 0 and 5. Integrate, I get 5x squared over 2. This looks a lot easier, this one. Minus x cubed over 3. 5's into there and 0 into there. 5 into that, I get 125 over 2. Minus 125 over 3. Minus nothing. I think that's 125 over 6 if you do it. Good, even was. So that's 3 examples we've seen, I think. And in class we'll do loads more. So exercise 12F. There's only certain questions, because there are some questions in exercise 12F I'm going to deal with next time, and I'm not going to show you that today. So don't do other questions than these, because you'll find there are questions, and it looks like, for instance, 2 and 3 maybe, I don't know. There are certainly some questions which deal with integration to the y-axis, and I want to deal with that another time. Thank you very much.